Hi, and welcome to another edition of Easy Theory. So let's do an example of the Towers of Hanoi problem. So this was a doubly recursive algorithm that we derived last time. And so what we want to do, let's just do an actual example to see this in action. So let's do this with 3 pegs, because if I do it with many more, it's going to be a really long video. So I have my 3 pegs right here. And in, let's just say green, I'm going to put the 3 cylinders. So remember, in the Towers of Hanoi problem, you have to, we want to move all of these, say, from here to here, utilizing this other peg if possible, such that I can't place a bigger cylinder on top of a smaller one. I can put a smaller one on top of a big one, that's okay, but I can't put a big one on top of a small one. So let's actually just follow the algorithm that we derived. So this says that we have n pegs, and we have we have n cylinders in our 3 pegs. Source is on the left, dest is on the right where we want to go, and utilizing the other one. Okay, so how do we actually do this? So we have at least n pegs, n cylinders, obviously, we have 3. So we want to recursively call Towers of Hanoi with these other parameters. So I want to move 2 pegs from the source to the other peg. So I want to move 2 from here to here. So let's actually just model what's calling what functions are calling what. So I'm going to abbreviate it to TOAD, Towers of Hanoi, so I don't have to write it over and over. We were calling 3, and with the source, and we want to move them to dest, utilizing the other. And this was recursively calling Towers of Hanoi with 2, source, other, and dest. Okay, so the actual parameters really matter here. So let's see. So we're trying to move 2 from this left peg. I should actually write these down. So this one is the source, the actual source. This one is the destination, and this one is the other. Okay. So what are we actually going to do here? Well, n is at least 2 in this case. So this one's going to recursively call Towers of Hanoi with 1 less. The source is still going to be the same, but these 2 flip-flop. So actually, if you look at the algorithm up here, dest and other are flip-flopped in the first recursive call, and the source is still the second parameter. So here, we're going to flip-flop and have dest other. So we're going to try to move 1 peg from the source to the destination, and maybe utilizing the other one. Well, n is at least 1 here, so that means we need to do another recursive call with 1 less, which is 0, and then the source stays the second parameter, and we flip-flop the other and the dest parameter. So this one becomes other and dest. So I'm going to try to remove 0 pegs from the source to the other peg, maybe utilizing the dest one. But notice that the number of pegs here is 0. So this one doesn't actually do anything, because in the algorithm, we only proceeded if n is bigger than 0. If we have no pegs to move, we're done. So this is saying we need to move 0 pegs, so we're done with that particular call. But we're not done with this call, which is asking for 1 peg to be moved. Well, this says move 1 peg from the source to the destination. So we're done with this recursive call right there. Now it says move 1 cylinder from the source to the destination. So we're going to follow what that says. Move 1 peg from the source to the destination. Well, the destination is dest in this case, so I want to move, let's make it smaller. So we moved 1 peg from there to there, and we're now going to go down the other recursive call, which is this one right here. So, so we did the move. Now we're going to recursively call Towers of Hanoi, again with one less. And so it doesn't even matter what the other parameters are because n is 0 in that case, so it doesn't matter what happens. Well, actually, nothing will happen. Okay, so we're done with Towers of Hanoi, this recursive call right here. So this one's done. Okay, so now we want to move 2 pegs from source to the other and using destination if possible. Okay, well, this is, so let's actually look what happens. So we moved 1 peg from the source to the destination. So now we're back into this, so we did this recursive call. Now we need to do this one, which is moving 1 cylinder from the source to the destination. Well, in this case, the source is still source. The destination is other in this case. So we need to move, so the next recursive call is Towers of Hanoi with 1, oops, no, not quite. I need to do the actual moving first, which is moving 1 peg from here to the other peg because that's the destination in this case. So I'm going to remove that cylinder and I'm going to put it over here. And so we're done with that. So then now what we need to do is to do another recursive call, which is Towers of Hanoi with 1 less than it had before, which is, so it's 1. And then now we got to figure out what is the source and the destination. So the order of the parameters is other here. So other is first, but the third parameter here is dest. So here, dest is first because in the original algorithm, the third parameter becomes first in this second recursive call. And then the other parameters are the second one. So it's basically the 3 parameters in backwards order. So it would be dest, then other, then source. Okay. Well, let's see. So if we actually go down this recursive call, what is this saying? This is saying move 1 peg, 1 cylinder from dest to other. Well, we know what's going to happen there. This one is going to move on top of here. So I'm just going to make it a little simpler and just say that we are actually done with this recursive call because that's all that's going to happen there. Okay, so I'm assuming that we've actually done this, even though this does have, this does have 2 recursive calls, but I'm not going to actually go down that because it would just be way too, you know what's going to happen there. Okay, so all we need to do now is to handle this top level function, which we're done with the first recursive call that the top level function did. So again, we need to move 1 peg from the source to the destination. So in this case, we need to move 1 peg from the source to the destination. So that's what we're going to do here. Move 1 peg. And then now, what we need to call is all 3 parameters again, all 3 parameters in backwards order again. So we need to call TOH with 1 less than it was before, and then the 3 parameters in backwards order. So it's other, dest, and source in that order. So other, dest, and source. Okay. Well, what is that really asking? That's asking, can we move 2 cylinders from the other peg to the destination peg? Well, that's exactly what we want to do. So let's actually try to visualize this one because it's actually where it gets interesting. So this one's going to make that recursive call, TOH with 1. So what is the order of the parameters here? Well, in the first recursive call, the second parameter stays the same, so other is still here, but these 2 flip-flop. So it's going to be source and destination. Okay, well, what does that mean in our picture? That means that we need to move one of them from the other to the source. So we need to move one cylinder from here to the source. Well, we know what's going to happen there. That's going to move one of the cylinders to the source. Then what do we need to do? What we need to do is to move from one of the cylinders from the source to the destination. So from the second parameter to the third parameter. So from the second parameter to the third parameter, well, okay, that's actually what we actually did. Okay, so I don't need to consider that. And then the other recursive case is TOH with 1 and these 3 parameters in backwards order. So that's going to be source, dest, and then other. Okay, so it's asking, can we move one of the cylinders from the source to the destination? Actually, did I do that right? I may have not done that right. So let's just be sure I did that right. So the first recursive call switches the order of the last 2 parameters, which we did. And then the second recursive call does them in backwards order. Okay? So this is asking, can we move them from the source to the destination? Other to source. Actually, I'm going to do a little cut right here to see what I actually missed. Sorry about that. So I figured out what was wrong. It's because I didn't do the intermediate step. The algorithm is right, but I didn't do the intermediate step. So let's actually refresh ourselves. So this is saying, do the recursive call, then move the cylinder from the source to the destination. Well, the source in this particular recursive call is the other peg, and the destination is dest. So we need to move one from the other peg to the destination, which we know how to do. So this is how it should be after that intermediate step. And then now we need to do the other recursive call, which is in moving one from the source to the destination. And we know what's going to happen there. So that's going to move this peg, this cylinder to here. Okay, sorry about that. So that's the Towers of Hanoi problem, which is a really nice use of recursion and showing what the inductive cases are and what the base cases are, where we don't even need to think about anything other than just handling one peg and one cylinder and n-1 other ones. Assuming we know how to move n-1 of them at the same time, well, how do we deal with that very last case? We utilize the third peg, move one of them there, and then try to move the n-1 on top of that. Okay, so it's actually a really cool problem. And one thing that would be really interesting is how can we actually generalize this? So if we have more pegs, does the problem become easier? Can we make better recursive calls? So let me know down in the comments what you think about that. And as always, I'll see you next time.